Hello everyone, welcome back to my channel. It's that time of the year again. I know a lot of you guys have been asking me to do this video and it's finally here. So today I'm going to be doing predictions for the IGCSE physics for the October-November session. I know you guys have your exams in like a few days, so I'm trying my best to release this video before your exams come out. Hopefully it helps you out. So in this video I'm going to be going through each topic and also predicting what's coming throughout those paper for each topic. And also I'll be showing you some tips and tricks. Let's begin. So the first topic, as we know, is physical quantities and measurement techniques. So this is, as you can see, this is one of the least common topics. So it has a 1% chance of coming up, and it's usually when it comes up, it's either it doesn't come up or it's 1 mark question. So what do you expect? What do you expect from this one, or what they ask you? So the first one is scalar and vector quantities. This one is the most important one, or the most common one. So they can give you a list of quantities, and they can tell you to identify which one's scalar and which one is a vector quantity. And the next one is resultant vectors from diagrams. So now this one is an important one, but this one you can also classify it as a force question. But this one, it's usually 4 marks. So make sure you know how to understand this and how to use resultant vectors. So maybe they can give you a speed in one direction. Let's say this is 4 meters per second and a horizontal speed, velocity of 6 meters per second. And they can ask you to find the resultant speed. The resultant velocity, which is a vector. So make sure you understand how to do those. I've done a video on this. I will definitely link down in the description below. And the second one is motion. Motion. So there's an interesting trend with motion for the 2025 papers. So the probability is 6% and it's usually up to 5 marks. So 5 out of 80 marks in that paper is going to be motion. So what do they ask you? They can ask you to calculate velocity, acceleration, and distance. So make sure you know and understand all the formulas. And the next one, this point is the most important one, using different motion graphs. So I've seen it come up so many times in the newer papers, the 2025 papers. Every time there's a motion graph. So they can ask you to find distance, which is area under the graph. They can ask you to find velocity and even acceleration. And this depends on what type of graph you're given. So make sure you know and understand how to interpret the 3 types of graphs. So we have speed time graph, we have distance time graph, and we also have the less common one, acceleration time graph. So make sure you understand all 3 of them. So if you're really not sure about these graphs, I've done a crash course on all the topics for IGCSE physics, which I will link down below. So make sure to check that out if you have any weak points in any of the topics. So the next one is understanding freefall and terminal velocity. So this topic, it hasn't come up much in the newer papers. So, but then we still need to understand it just in case Cambridge decide to switch it up. So freefall. Freefall is when an object is released with no force downwards, and the only force acting is gravity. So free falling object with no air resistance will have acceleration of 9.8 meters per second squared. You should understand this and also be able to explain terminal velocity. What is terminal velocity? So let me give you a quick recap. So let's say we have a rock falling down. So as the rock is falling down, there's 2 forces. We have the weight and we also have the air resistance or drag. Let's call that F. So we have 2 forces. So as the speed is increasing, So when velocity increases downward, the air resistance or the drag or this force F increases. So that means the object, this rock over here, will eventually have equal upward force and equal downward force. That means resultant force is 0. So maybe at this point, maybe weight is greater, and then after a while, weight will be the same as F. And then that's terminal velocity, where there's no change in velocity or constant velocity. So if we were to graph terminal velocity, let me just graph it over here. It would go something like this. So we have velocity, time, it would go something like this. It would straighten. So this is the graph for terminal velocity. The third topic is forces. Forces, now this one has increased and it has been coming up a lot in the newer papers. So it has a probability of 13% and about 11 marks per paper. So what can you expect? So usually there's mass and weight. So know how to calculate weight from mass. So it's weight is mass times 9.81 basically. So this mass and weight questions usually are connected to the motion questions. So maybe if there's a motion question, expect also a mass or weight question. The next one is density. Haven't seen that much, but then also know the formula. Density equals mass over volume. The two common ones are turning effect of forces and momentum. Momentum, I've seen this come up multiple times, and this is probably one of the hardest force questions that I've seen in a while. So there's gonna be questions about momentum. So make sure you understand conservation of momentum, and also make sure you understand the reason behind recoil velocity, because I've seen a 4-mark question recently on this specific topic, recoil velocity. So what happens is the question goes like there's a spaceship and then there's a small pod connected to the spaceship, and then the pod goes forward and it separates. So now it's something like this, and they have different masses. We have a velocity v1 and then also another velocity v2, and they asked us to find the velocity. So make sure in this you have to understand how to use momentum to find the velocity. And that's the main concerns with forces. And center of mass, it could appear, but I haven't seen it that much lately. So the next topic is gonna be work, energy, and power. So this topic, it has significantly decreased throughout the years. So probability is about 4% and about 3 marks per paper. So 3 marks, that's the average of all the papers combined. But usually what happens is it's usually 6 marks per paper or there's no question on it. So sometimes you can get it, or sometimes if you're lucky, you're not going to get any questions related to work, energy, and power. But in case you do, what can they ask you? Forms of energy. So make sure you understand kinetic energy and gravitational potential energy and understand like the conversion between them. So what I've seen recently is like there's a track over here and there's point A, there's point B, and also point C. And then maybe there's a moving object down here. And then they can ask you what type, like the transfer of energy, maybe the energy up here and then at point B and then at point C. So make sure you can explain that well. It's usually about 3 marks. And the next one is energy resources. So like there are different energy resources, like there's the sun, and there's hydraulic energy, nuclear energy, geothermal energy. But this one haven't seen it much often. And next one, work done, efficiency. So work done, make sure you know the formula. Work done is force times distance and efficiency. You will be asked to calculate efficiency, or what I've seen most times is they'll give you the efficiency of a machine or anything, and then they would ask you to determine something. So make sure you know the formula for efficiency and how to calculate it. Next one is power. Power is also a common one, so you need to know the formula for power and also the unit for power. Again, if you're not sure about any of these topics, I've gone through them in my crash course, which I will link down below. Now, this is the interesting one so far. Pressure. So this one, surprisingly, there is zero probability of 0% because recently no pressure questions have come up. In the 2025 papers, there's no pressure questions. Like Feb, March, May, June, no pressure questions. That's very interesting. I was surprised by that. I even checked on the syllabus just to make sure that pressure is still there, and it is. But for some reason, Cambridge decided not to bring up any questions. So I highly doubt this question will show up in your paper, but Cambridge might decide to switch things up and then bring up that question. And if they do, what is the usual questions they come up with? The first one is pressures in solid and liquids. Know the formula. In solids, it's force over area. Liquids, it's density times gravity times height. Make sure you know these two formulas, and also how area affects pressure. Make sure you understand that. So how it affects it is as area increases, pressure decreases. They're inversely proportional. And the most common one is particles in a container. Make sure you understand how to explain that, like how a particles in a container exert pressure. So let me give you a quick recap. This is usually 3 marks. So let's say we have a container and there's some particles, gas particles, let's say. And then how do they exert pressure on the walls of the container? So what happens is these gas particles are moving randomly at high speeds, and then they'll collide with the walls. So when they collide with the wall, they're going to exert some amount of force in a specific area. So since pressure equals force over area, that means that there's going to be pressure on the walls of these containers. And also make sure to mention momentum. So when these particles exert force on the wall of the container in a specific amount of time, force is change in momentum over time. So they exert force, and that force exerted over an area, that's going to give us pressure. Thermal physics. So this topic has a probability of 7% and about 6 marks per paper. So what do they ask you? So make sure you understand the 3 states of matter and also the particle model. So the specific characteristics of the particles of the 3 states of matter. And the next one is thermal expansion and specific heat capacity. So specific heat capacity is an important one. Make sure you know the formula and how to apply it. One thing I've seen in commonly is that these days Cambridge is combining thermal physics with electricity. So they can ask you to they'll give you like some amount of time and tell you that the amount of thermal energy transferred. So make sure you know how to use this formula. E equals to I dt. So E is electrical energy, I is current, V is voltage, and T is time in seconds. So maybe they can give you like the efficiency of a machine, and let's say 95% efficient machine is producing energy of 1000 joules, electrical energy of 1000 joules, and it's 95% efficient. If it's 95% efficient, that means 5% goes to thermal energy. And they can ask you to calculate any of the I, V, or T. So make sure you understand that. And the next one is transfer of thermal energy. The three types: conduction, convection, and radiation. And when it comes to convection, make sure you understand how the convection current works. So if you don't know what a convection current is, let me give you a quick recap. So let's say we have a container and then we're boiling water. So there's going to be some water. So when you're boiling this water, the bottom part gets hot. So when it gets hot, it gets less dense. So that means the hot water goes to the top, and the cold one, the one on top, sinks down. And then when it sinks down, it gets hot again. So that means this is a repeating cycle. The hot water comes up, the cold water sinks, and then it continues again and again until all part of the water is hot. This is what we call a convection current. This also works with air particles, not just water. Next one is waves, the second most popular topic in IGCSE physics. So probability of 18% and about 40 marks per person per paper. What do they ask you? They can ask you about property of waves. So reflection, refraction, and diffraction. Make sure you know these and I can identify them. And they can ask you about light, electromagnetic spectrum, and sound. And the most common one, and I've seen this appear so many times, I cannot stress this enough, wave diagrams. Make sure you know how to interpret wave diagrams. So if we have a wave diagram here, if we have a lens here, and also an object here, make sure you know what type of image shows up on the other side. And make sure you can determine how to make sure you know how to determine what type of image shows up. So if we have here, this is the center of it. And this, make sure you know, and then we have the principal focus. And then make sure you know how to draw those lines so you can determine the nature of the image. So this one quickly goes through the center. The first line you're going to draw goes through the center and then goes through the principal focus. The second one just goes through the center point. Something like that. And then this is where the image forms. As you can see, it's upside down or inverted. It's also smaller and it is real. The image is real. So make sure you can do that with different types of lenses, and also with different positions. So if the object was here, it would have been a different story. Now this one also surprised me a lot because electricity and magnetism, probability of 28% or 22 marks per question per paper. So this has increased so much. This is basically almost half of the paper. And then there is one paper in which I've seen 28 marks are for electricity or magnetisms. 28 out of the 80 marks. That's 35%. So make sure you understand this topic. Understanding this topic could be the difference between getting a C and getting an A. So what can they ask you? They can ask you about electric charges and how they interact, electric circuits and circuit components. Make sure you know the symbol for the different components, and also make sure you know the formulas and to calculate, to do different calculations in electric circuits. So the one I mentioned earlier, E equals IVT, power equals IV, and the most important one, Ohm's law, V equals IR. And also make sure you understand magnetism and how magnets work. And the one I've seen so many times is magnetic effect. This time it's usually DC and AC generators or motors. So make sure you understand the different parts, make sure you can name them, and also you can name the function of the different parts, especially AC current, and also understand the graphs of AC current. This sine pseudograph. Make sure you know how this graph works, and then make sure you know how to draw this graph, because I've seen questions on that. The ninth topic, nuclear physics. So the probability is about 10% and 8 marks. So what do they ask you? They ask you about the atom, radioactivity, radioactive decay, and count rate. I've seen this multiple times, especially connected to the half-life graphs. So I've seen the half-life graph multiple times. Also, half-life tables. So you can expect these, and also make sure you know how to finish decay equations and understand the different types of decay equations. There's alpha decay, beta decay, gamma decay. Understand which one's which, and make sure you can identify it. The last topic, space physics. So it has a probability of about 11% and 9 marks per paper. What do they ask you? They can ask you about the Earth and the Moon, mainly about orbital speed, and also the solar system and life cycle of the star. So make sure you understand the life cycle of a star. It can be a giant star or a small star, which have different life cycles. Make sure you memorize those. It's usually about 3 marks, those questions. And lastly, universe and Hubble's constant. So that's all for today. So if you guys have any questions or comments, make sure to drop them down below. And if you're unsure about any topics, I have linked down uh, my crash course in the description. So make sure to check that out. It's a lifesaver. So thank you for watching.